The Illustrated Encyclopedia of the Elements, the Powers, Uses, and Histories of Every Atom in the Universe by Lisa Condon. Introduction. When I was a little girl, I would sit at the kitchen table and watch my father work. After dinner, he would write equations on graph paper. I knew he was a scientist, but the inquisitive handwritten equations were all I knew about what my father did in his career as a physicist. At that time, I was intrigued, but science seems mysterious and complicated to me. It wasn't until I became an elementary school teacher in my early 20s and began teaching various science subjects to my students that science came to life for me. I loved learning with my students about the elements that make up the universe. Years later, I am no longer a teacher but a professional artist. So, what is an element? Everything in the world, what you see and feel, your body, the ground you're standing on, the book you're holding, the stars in the sky, is made of elements. There are 180 known elements in the universe, more than 90 are naturally occurring on Earth, and the remainder are human-made. In turn, the elements are made up of gazillions of tiny atoms. A single element is a pure substance that is made from one kind of atom and can be broken down into any smaller, similar substances. For example, the element hydrogen contains only hydrogen atoms, and the element silver contains only silver atoms. All about atoms. So, as you can see, the positive charge in the nucleus is the protons, and the neutral is the neutrons. And you can see that there's things that orbiting the nucleus is the electrons, which the negative charge. So, the atomic number is 2 with the helium, and the atomic mass number is 4. So, what is a helium? Helium, or He atom, was 2 protons, so its atomic number is 2. The atomic mass, the weight, of helium is 4 and is measured by the sum of protons and neutrons in the atom. The number of electrons in an atom doesn't affect either measurement. Small wonder, atoms are so tiny that they are too small to see except with extremely powerful microscopes. Every atom has a dense center called a nucleus. Forming the nucleus are 2 kinds of particles: protons, which have a positive electrical charge, and neutrons, which have no charge. Bound to the nucleus are 1 or more electrons, which are particles with a negative charge. Scientists use to describe atoms as tiny solar systems with an electrons orbiting around the nucleus like planets around the sun. But atoms are a lot hazier than that. If you imagine the tiny nucleus as a pea, it would be centered in a football stadium. Science cloud includes the electrons. We can't be sure why the electrons are because they're impossible to pin down. Protons, we've got your number. All atoms have at least 1 proton in the core, and protons determine an atom's uniqueness. The number of protons determines the element. For example, hydrogen has just 1 proton. No other element is made up of atoms that contain 1 proton. For this reason, we list the different elements by the number of protons. This is called the atomic number. The atomic number determines what the element sits on the periodic table of elements, the organized chart of all the elements that have been discovered. Neither here nor there. Neutrons have neither a positive nor a negative charge. No matter how many neutrons are in an atom, they do not affect the charge. However, neutrons do affect the mass, or the weight, of an atom. The atomic mass is the sum of all the protons and neutrons in the element. Electrons in orbit. In addition to protons and neutrons, all atoms have electrons. Electrons are negatively charged particles that orbit the space surrounding the positively charged nuclear core. These orbits are called electron shells. Each electron shell has a different energy level, with the electron shells furthest from the nucleus having the highest energy levels. This outermost shell is known as the valence shell, and the electrons found in it are called valence electrons. The number of electrons in the valence shell determines the atom reactivity or tendency to form chemical bonds with other atoms. Atoms are more stable and less likely to be reactive when the valence shell is full of all atoms it can hold. In balance, neutral atoms have an equal number of protons and electrons, and the number of protons and neutrons is usually the same, but sometimes not. Adding or removing neutrons to an atom makes an isotope, a heavier or lighter version of that same element with the same chemical properties. Changing the number of electrons in an atom also does not change the type of element it is, but it does change its chemical behavior. The atom is no longer neutral in charge and now is called an ion. But adding a proton, suddenly you've got an entirely new element with, you guessed it, a new atomic number. Here's some fact about atom. An atom is about 1 angstrom of diameter, which is about 100,000 times smaller than a red blood cell. Electrons travel at a speed of 1,376 miles, or 202,000 kilometers per second, and at this speed, they could orbit Earth in 18 seconds. 99.999999999% of an atom is empty space. A single human hair is about as thick as 100,000 atoms. Make a fist. It contains about 15, I know how to call this word. That's 15 septillion atoms. If each atom in your fist was the size of a marble, your fist would be the size of Earth. Oh my goodness. So that's it. Tomorrow I'll read the rest of it. No, not the rest. I'll read about compounds and states of matter. Yeah, and something like that. So bye.
Mỗi ngày con đọc một cuốn